How are you, students? Welcome to our series of our lessons, online lessons. And today we want to look at Form 1 Physics in our continuation of the topic of heat transfer. Specifically today we are going to look at comparing conductivity of metals and other materials, conductivity of solids in other words. We want to look at how solids conduct heat. The objectives here is that you as the learner should be able to explain conductivity of different metals and non-metals. My name is Mr. Joha, and going forward we simply want to look at comparing thermal conductivities of various conductors. This is an experimental activity. It is an experimental activity and it takes longer time, more than the time we have in our online class. But what we need is the rods of aluminium, iron, brass, copper, glass, and all must be the same length and cross section. This is a constant for all of them, that they must be having the same length, they must be having the same cross section area, so that there will be no variation in some factors. All these we have mentioned: aluminium, iron, brass, copper, glass are solids, and we want to see are they conducting heat at the same rate. So, if they are of the same length, and we will fix wax on the surface, or at the end of those metal rods, we fix wax. We know wax can easily melt once it gets heat. So we fix wax so that when the heat reaches there, the wax will melt, so that we observe the thermal conductivity of all those rods. Then we put them in a container of water that we are going to heat with a source of heat. The experiment looks like this, where we are going to compare all those solids: aluminium, iron, copper, brass, glass, wood, and we see which one conducts heat faster than the other one. The procedure here is that you set the apparatus as we have shown on the diagram. Ensure that the rods are held firmly. Those rods are held firmly. So pour boiling water into the containers. That one will act as a water bath. So the hot water bath is used to form the uniform heating of the rod, so that it can heat the water at uniform rate. So then we observe what will happen on the wax. The rod that the wax melts earlier than the others means that it conducts heat faster. So we list the rows with the one, starting with the one that conducts heat faster to the one that conducts heat at the lowest rate. So we are going to look at this video and see the results, because we cannot do that experiment because it takes longer, but we can have it here in our video and see exactly what is going to happen.
Hello, I am Mr. Tan and my partner is Mr. Fan.
Hi everyone, and welcome to our physics demonstration on conduction.
Conduction is a form of heat transfer through a medium. Our experiment here is to investigate how fast conduction occurs through different types of solids. Let's see the setup now, shall we?
As you can see, we are going to use different types of rods to conduct the heat from the hot water to the candle wax at the far end of the rod. The rods used in this experiment are copper, aluminium, brass, iron, lead, and finally glass.
These rods are secured with a rubber stopper to the empty metal pot, with only a part of it exposed to the hot water. Mr. Fadil, can you kindly start to pour hot water into the pot?
Sure, when I pour hot water into the metal pot, all the rods will be heated up and at the same time conduct heat to the candle wax. Given enough heat, the wax will ultimately melt. Hence, the faster the candle wax melts and drops from the rod, the better the conductor of heat the rod is. Let's wait and see.
The wax from the copper rod dropped first, followed by the wax on the aluminum rod. Why?
Let's move on to part 2 of our experiment.
Thank you very much. Now, we have seen that we can compare the conductivities of different metals and non-metals. From the observations that we have seen is that the different materials have different thermal conductivities. Metals are generally good conductors of heat than non-metals. In other words, what we have seen from there is that we saw copper. Copper is the one that whose wax started melting, melted and fell off, followed by aluminium, and then the other metals followed later on. The iron, the lead, that is copper started, aluminium followed, brass followed next, then there was lead, and then brass, iron, then glass, and glass was the last one. In fact, glass took much longer time, which we could not show here because it is a poor conductor. So generally, metals are good conductors of heat, while non-metals are poor conductors of heat. They are insulators. We call them insulators because they do not conduct heat, while metals conduct heat, although at different rates, as we have seen from our experiment. So, why do metals conduct heat much faster and than non-metals that are poor conductors? Is because metals, as we discussed in our previous lesson, metals have free electrons. Metals have free electrons. Therefore, they conduct heat. By the free free electrons, and they also conduct heat by vibration of the atoms. So in other words, metals conduct heat in two ways: by free electrons carrying the heat from the heated end to the other unheated end, and also by vibration of the atoms. From the heated end, the atoms vibrate very fast and then collide with the next or neighboring atoms and transfer the heat that way. However, the fastest way of transferring heat is by the free electrons. While nonmetals, which we are calling them insulators, do not have free electrons. They do not have free electrons, so therefore that method is totally not there. They conduct heat by vibration of the atoms, which collide with the next atom and therefore transferring the heat that way. And remember that as they transfer heat that way by vibration of the atoms, that way is the slowest method. It is a method that is slower than the method of free electrons. So in other words, the conduction of heat in nonmetals will not be very effective because of the way they conduct the heat by vibration of the atoms. So let us be around to see our next slide.